Oops, sorry, wrong announcement. Today we're looking at polynomials and equations, so we're going to be reviewing some of the operations with polynomials and solving linear equations. So this is stuff that you guys have seen before in grade 9, but we're going to be reviewing this as a lead into Unit 2. So first thing we're going to take a look at is adding two polynomials together. When we add two polynomials together, we want to remove the brackets. The brackets are kind of a waste of time when we are adding two polynomials together. So all we do in this case is we rewrite everything without the brackets, and then we solve it from there. And the way we solve it from there is we collect like terms. So if I'm looking at the four terms that I have here, I've got two terms that have an x in them, and I have two terms that have a y in them. So if I collect the x's together first, 3x plus 5x is going to give me 8x. And then the y's, I have a plus 4y and a minus 2y, and that's plus 2y. So my final answer there is 8x plus 2y. The x and the y are not like terms, so I can't add them together. So that's my final answer in that situation. When I'm subtracting two polynomials, that's a little bit different. The first bracket is not affected at all. So 3x plus 4y I can rewrite without the brackets. But the rule is that when there's a subtraction sign in front of a bracket, it's going to change the sign of everything inside that bracket. Or if you want to think of it, it's like there's a minus 1 in front of that bracket, and that minus 1 is going to multiply by each term inside the bracket. So the plus 5x in that second bracket changes to minus 5x, and the minus 2y changes to plus 2y. Once we've done that, then we are going to collect like terms again. So we've got the x terms, we've got the y terms, and when we collect those together, 3x minus 5x is minus 2x, and plus 4y plus 2y is plus 6y. And notice when I'm trying to collect the like terms together, I'm just using different underlining symbols to show the like terms there. When we are multiplying monomials together, we've got kind of different parts to these things. All of this is all multiplying together. The 3 that's out in front here and the minus 5 that's out in front here.
Do we have a custodian to the main office, please? Custodian to the main office?
The coefficients that are out in front are regular numbers. So the 3 and the minus 5, we'll end up multiplying those together because they are both coefficients there. And then the rest of the stuff that comes after that is we've got an x squared, we've got an x to the exponent 5, so they're like each other, but they're being multiplied, and then we've got y cubed. And when we actually multiply all this stuff together, the 3 times negative 5 is going to give us negative 15. When we're multiplying the x terms together, we add the exponents together, so that's x to the 7, and then y cubed just goes on the end. So this is what our final answer looks like when we do this. And you can certainly, I've written that middle step, but you can certainly make the jump from here to the final answer by multiplying the coefficients together to get the negative 15, and then adding the exponents on the x's together to get x7, and then y cubed. There's no other y part of that, so we can just write y cubed for that one. The distributive law happens when we've got a monomial out in front of a bracket, and if that bracket has more than one term on the inside, then we have to distribute the 5x. So the 5x has to multiply by the 3x squared, and it has to multiply by the 2xy.
Take the custodian to the main office, please. The custodian to the main office to show someone to a room.
And we use the same rules we did up above. So if I'm multiplying 5x times 3x squared, the 5 times 3 gives me 15. And I have to be careful, there's a 1 on that x there. So the 1 and the 2 add together to give me a cube on that x. And then 5x times 2xy, 5 times 2 gives me 10 for the coefficient. And I add the 1's on the x's, so that's x squared, and then the y goes on the end. And that's my final answer. I can't add those together because they are not like terms, so that's my final answer. Sometimes the distributive law gets a little more complicated. Here we're asked to expand and simplify. So for the expand part, the 5 in front of this first bracket, 5 times 2x is 10x, and 5 times negative 1 is negative 5. And then I have to multiply negative 4 inside the second bracket because it's right up against that bracket. It's multiplying. It has to multiply by each term inside that bracket. So negative 4 times x squared is negative 4x squared. Negative 4 times 6 is negative 24x. It's multiplying by 6x there. And negative 4 times 3 is minus 12. So that step there was the expand. This step here is going to be the simplify. And to simplify here, we're just collecting like terms. So I've got a 10x that is like a minus 24x. And I've got a minus 5 and minus 12 that are like terms because they're constant terms. They don't have any variables with them. Now, when I'm writing my answers, the back of the textbook and typically anything that's published in math always likes to write the term with the biggest exponent first. So the biggest exponent we have is x squared. So we're actually going to write the minus 4x squared at the beginning. Then we've got a couple of x terms that we need to collect together. So 10x, take away 24x is minus 14x. And then I've got a constant term of negative 5 and negative 12. And when I total those together, I get negative 17. So that's my final answer for that question. Next up, we're going to review solving equations. So the golden rule of algebra, whatever you do to one side of the equation, you must also do to the other. So when we're solving, so here's an example of an equation here. And remember, in an equation, we want to isolate the variable. So it's kind of like we want to collect like terms. So, and I've got the process written on the side here so you can follow along. First thing I'm going to do is I really want to collect the x's on the left side here and the constants on the right side. I could do the opposite, but often we like to collect the variables on the left side. So first thing I'm going to do is I'm going to move the 12 to the other side. And the rule is that I have to do the opposite operation. So on the left side, I'm going to subtract 12. On the right side, I have to do the same thing. I'm going to subtract 12 there. On the left side, that eliminates the plus 12. And on the right side, I'm going to have 8x, and then minus 2 minus 12 is going to give me minus 14. Next up, I'm going to get the 8x, and it's going to be moved to the other side. So I have to do the opposite operation. So I'm going to do a minus 8x on that side and a minus 8x on the left side. So 15x minus 8x will give me 7x. And on the other side, I'm going to, the two 8x's here, 8x minus 8x gets rid of the 8x that we had there. So we have 7x equals minus 14. And the last thing we're going to do is, to isolate the x, we have to get rid of this 7 that's multiplying. So we're actually going to divide by 7 on each side. So we end up with an answer of x equals negative 2. And I've shown all the steps here. You do not have to show all the steps here. You can shorten that up. So I'm just showing you all the steps here for the first time through. So what about dealing with fractions when we're solving equations? We really want to get rid of the fraction. So we're going to talk about first what we can do to get rid of fractions. So if I have a number like 3/4 and I want to get rid of that 4, I could choose, if I multiplied that fraction by 4, then these two 4s would divide out and we'd be left with a 1 there. And if I calculated then 3 times 1, that would get rid of the fraction. Then I'd have 3. So think about it. Is there another number that I could multiply 3/4 by that would get rid of the 4 that's on the bottom? So another number we could multiply by that would get rid of the 4 would be 8, because 4 divides into 8 2 times. So if I did that, that's going to get rid of the fraction as well, because 3 times 2 will give me 6. There's no denominator, so I'm good to go. So the bottom line is that to make a fraction disappear, you need to multiply by any multiple of the denominator. So, in this first question here, we have 2 denominators. So, we're going to multiply each term by the lowest common denominator. And if we're working with 3 and 2 as fractions, our lowest common denominator would be 6. So I'm going to put a bracket around each term here. I've got a term there, a term there, a term there, and a term there. So terms are separated by adding, subtracting, or equal signs. And then I'm going to multiply each of these terms by that lowest common denominator. I'm multiplying everything by the same number, so I'm not changing the equation in any way. And remember why I'm doing this. I'm doing this so that I can divide out the denominators. 3 goes into 6 2 times, and 2 goes into 6 3 times. Those are the only 2 denominators. They're the only things that I have to divide out. And then I have to clean up the garbage here. So here I've got 2 times 5x, that's 10x. I've got minus 6 times 2 is 12. I've got 3 times 1x, that's 3x. And then 6 times 3 is 18. So I've got an equation here. Now, on this next step, I'm going to collect like terms. So a shorter way to do what we did up above with the equations is to collect the like terms. So I'm going to leave the x terms on the left side, so 10x. If I bring this 3x to the other side, it's going to change to minus 3x. So I've collected the x terms together. On the other side, I've got 18 that's there already, and I'm going to bring this minus 12 over to collect the constants together, and it's going to change from minus 12 to plus 12. So we have 7x equals 30, so we end up with 30 over 7, or if you want to write it as a mixed number, you could write it like that. Okay, and that's how we handle a fraction. Now, a more complicated fraction question is this one here. Our lowest common denominator would be 24 for these 2 numbers. There's actually only 2 terms here, so because the fraction bar, the 2x plus 1 over 3 is all one term. So I'm going to multiply each of these terms by 24, which is my lowest common denominator. And then remember why I'm doing this. 3 goes into 24 8 times. 8 goes into 24 3 times. Let me just move this guy over. Okay. And now the thing we have to be careful of is that this 8 has to multiply by both parts of that numerator. So I'm going to get 16x plus 8 on this side. And on the other side, I'm going to get 3x minus 18. Then I collect like terms. So the 3x moves over to the left side and subtracts. And plus 8 moves to the end on the other side and subtracts. So I end up with 13x equals negative 26. And my last step, I divide both sides by 13, and I end up with x equals negative 2. Okay, we're going to be working on this stuff over the next couple of days for practice. Thanks very much. We'll see you tomorrow.